All right, ladies and gentlemen. So, hopefully you're doing all right. Hopefully you're feeling okay with what we did on Monday. If you haven't done that yet, please make sure you do that. That's going to be a way for not only me but for the school to be able to tell who can get in, who can't. So please make sure that if you have not done Monday, you pick that up on Tuesday. You go back and you do the stuff for Monday. It's mostly just getting back into the swing of thing type stuff. It's not going to be anything math or subject related. Now, Tuesday is going to be a little different. It will be subject related. And basically, what we're going to do is we're going to review what we left off with. For those of you who know what I'm talking about, and I hope everybody does, we were talking about interest, where if you put money into the bank, into a savings account, it would accrue interest. A certain percentage of the money every month would help your total to increase. And we talked about simple interest versus compound interest and how that looked different on a graph. In fact, I made this up real quick here. Not that, that's the main screen. We were taking a look at simple interest versus compound interest. And simple interest gave you the same amount every month. So that's the one in red. You start at $250 and you're getting this in this case it's 8%, so you're making $20 every month, but it's 8% simple interest, $20 every month. You're only making the interest on the 250 and always the 250. So 8% of 250 is 20. You're making $20 every month. And you can see it's a straight line, $20 every month. That $20 based on the 8% of the 250. The difference and this is straight, it's linear. We talked about this. Now, the word that might be new to you here is exponential. And that is 8% of 250 is 20. You can see this point right here is the same. They made $20 in the first week, but whereas the red one is just making 20 every week, the blue one is going to not just make $20, it's going to make 8% of that 270, which is going to bring you up to a bigger number, and it's going to keep going like that. You're going to make 8% of the last total, 8% of the last month, 8% of the last month, and you can see it's going up in a curve, and that is your exponential. And when I say exponential, think about what that sounds like. It sounds like exponent. Exponent right here. This x is an exponent. I know a lot of us usually see a number as an exponent. This would be after 2 months. This would be after 3 months, 4 months. We put an X for we don't know how many months. And so that's exponential. So that's the last thing we did. We did a problem very similar to this where we were looking at, oh, hey, an exponential thing, something with an exponent is going to go up faster, whereas linear is going to stay that constant, consistent rate. Okay, so this is not going to be brand new. We've seen this before, and we're going to probably pick up with this on Tuesday the 14th when official learning starts. This is technically review. Like I said, we're going to kind of review this. We're going to restart the chapter basically. But this, I think, is the simplest way to start. Okay. All you have to do here is highlight either linear or exponential based on whichever one you think it is. And I'm going to show you how to figure that out. Now, when I say highlight, so for example, if this is linear, you're just going to go to here, this little paintbrush that's highlight color. It looks like a paintbrush to me. It's probably a highlighter. And highlight the one you think it is. There it is. Now, is this linear or exponential? How can we tell? Now, we have the equation. And you're either going to have the equation, the table, or the graph. And this is what you're going to do. Take a look at this equation. Does it look linear? Now, linear meaning y equals mx plus b, right? Is it in the form y equals mx plus b? If it is, it's linear, and in fact, it is. This is in the form y equals mx plus b. Let me use my finger, y equals mx plus b. Our m is our 3, b is -7, and if we wanted to graph it, our y-intercept would be -7, so starting at -7 and then going up 3 over 1. So this is, in fact, linear. So you're just going to take your mouse, highlight linear in yellow. The other thing to think about is exponential means exponent, right? There's no exponent in here. There's no exponent, nothing to a power. And if we graph it, y equals 3x minus 7 in Desmos, might as well over here. You can do this. Desmos, y equals 3x minus 7. Let me go home. Boop. There it is. Straight line. It is linear. Use your resources. You can do this. Check out the next one. Y equals 400 times 1.02 to the power of x. It has an exponent. It is, in fact, exponential. I'll go ahead and check that in Desmos. Y equals 400. Desmos is a website. Desmos. I'll put the link in your in Schoology, so you can use this if you'd like. Times 1.02 to the x. 1.02 up to the x. Gonna have to find that one. There it is. It's a curved line. Exponential. If you see that curved line, you see an exponent, it is in fact exponential. Now, so key thing with equations, because they're going to look kind of similar, is first off, y equals mx plus b is linear. We know that. If it has a y-intercept and a slope, like this one, then we know it's linear. This one, it's not in the form y equals mx plus b. There's no plus or minus, and there's an exponent. Again, if you want to graph it. Straight line means linear. Curved lines means exponential. Now, when you go to take a look at the tables, this is what you're looking for. Remember, when it's linear, it's the same change every time you go up by 1. So for example, and actually let me zoom in real quick. Take a look at this table. Let's take a look at what's happening. You're going up by 1 on the x. Every time you go up by 1, you should go up. When I say go up, I mean add. Add by the same thing. So here, 2 to 4, you're adding 2. Here you're adding 4 to 8 is 4. 8 to 16 is plus 8. Now right there, you see, it is not consistent. You're adding 2, then 4, then 8, then 16. That means it is exponential, because it is not a consistent. So highlight. Oops. Exponential. Highlight it. All right, because if we graph that, it'll end up being a curve. Now let's check this one. It looks like we are subtracting by 2 on the x. So as long as the same thing is happening on the y, or not the same thing, but the same consistent pattern. It looks like 13 to 16, we're adding 3. 16 to 19, we're adding 3. Yep. That means that it is linear. So every time you subtract 2, you're adding 3 on the y. That's a constant rate. That means, that means that it is in fact linear. And finally, with the graphs, let me zoom out a little bit here. With the graphs, that is a curved line. It means it's exponential. Think about it this way. Linear means line, so that means the other one's got to be exponential. And this is a straight line here. My screen is freaking out for some reason. It is linear. And to relate it to the interest, simple interest would look like this on a graph, straight line. Compound interest would look like a curved line. If we were to write the equations, this would be our compound interest. This would be our simple interest. All right. So basically, what you're going to do then is you are going to go down here and you're just going to highlight which is which. If it's linear, highlight linear. If it's exponential, highlight exponential. There are 6 here, so you just need to highlight the way that I did up here. If you guys have any questions, feel free to email me or message me on Schoology. Good luck. Take care, guys. Have a good day.